All right, now we have unit 2. So this is about basic derivative rules. So number 21 asks us about the average rate of change. And when you see that, you should just think slope. So really what we're going to need is f of 5 minus f of 1 over 5 minus 1. So if you plug in 5 here, f of 5, you're going to get 5 squared plus 2 times 5 minus 6. So that's going to be 25 plus 10, so 35 minus 6 is going to be 29. Okay, then we have f of 1. So that's 1 squared plus 2 times 1 minus 6. So 3 minus 6 equals negative 3. So when we plug those in, we're going to have 29 minus negative 3 over 4. Minus a negative becomes a plus. So this is really equal to 32 over 4, which we know is equal to 8. So B. Okay, 22, we have this graph, and we're trying to see which order the derivatives should go. So let's start with, let's just look at A. So f of 0. So we're talking about derivatives, which means we need to look at the slopes. So f of 0, if we look right here, notice how that's a negative slope. And then we look at negative 3, they tell us that's a horizontal tangent line, so that's going to be equal to 0. And then if we look at the slope at 4, it's positive. So this is actually in the right order. So it's going to be A. If you look to the others, it would be saying that a positive slope is less than a negative slope is less than 0, which we know is not true. Or it would be that 0 is less than a negative is less than a positive. Again, not true. Negative, positive, 0. Not true. So A is the only one in the correct order. All right, 23. So looking at this one, we're going to need L'Hopital's again, because if you plugged in a 3, you're going to get 0 over 0. So with L'Hopital's, this is going to be the limit as x approaches 3. If I take the derivative of the top, we know the derivative of natural log is 1 over x. Then I have natural log of 3. That's just a constant. That's just some number. So the derivative of that is going to be 0. And then the derivative of the bottom, the derivative of x, is obviously just 1. The derivative of negative 3 is 0. So I'm left with 1 over x over 1. When I plug it in, I get 1/3 divided by 1, which just equals 1/3. So D will be our answer for that one. Okay, 24. Remember, when you see this, this is just asking for the derivative. So this is the definition, or rather the limit definition of a derivative. So even though these problems look extremely difficult, you should actually be glad when you see these, because all it's asking you to do is take the derivative of this function right here. So the derivative of sine x, we know just equals cosine x. So B. All right, 25, our best estimate of f prime. So if it's ever asking for the estimate of a derivative and they give you a table, once again, it's just slope. So really, we just got to figure out where does 3 fall, which is going to fall right here. So using the slope formula, we have 8 minus 5 over 4 minus 2, which is just going to equal 3/2. So our best estimate at our derivative is D. 26, we have the derivative of 1 over x plus 1 over x squared. Let's go ahead and change these to negative exponents. So x to the negative 1 plus x to the negative 2. And we take the derivative, we get negative 1, x to the negative 2, minus 2x to the negative 3. And now obviously our answer choices don't look like that, so we can go ahead and change it, and we get negative 1 over x squared minus 2 over x cubed. So if we're trying to match here, it looks like our answer is going to be C, because that's the one that matches this one exactly. 27. Once again, let's change these to, so it's already as an exponent for this one, but then we're going to change this to plus 3x to the 1/2 power. So then my derivative is going to be 3/2 x to the, if we take the 3/2 exponent, subtract 1, we're left with 1/2 plus 3/2 x to the negative 1/2. So to make this look like our answers, it should really be f prime of x equals 3/2 square root of x plus 3 over 2, that square root will go on the bottom, which looks like C. Okay, 28, we have a piecewise function, and they want to know which of these is true. So continuous, let's just take a refresher here. Continuous means the limits are the same. Oops. And it equals the point. Differentiable means that the slopes are the same on both sides. So let's first just see if this is continuous. And remember, if it's not continuous, it can't be differentiable. So to see if it's continuous, we're going to make sure the left limit matches the right limit. And notice how this one has the equal to line, so we don't even have to worry about the point. So when I plug in the left, it's going to be negative 2 plus 5 equals negative 2 squared plus 2 times negative 2 plus 3. So I get 3 equals 4 minus 4 plus 3. So 3 equals 3. So right there, we know it is continuous. So anything that says it's not continuous, we can get rid of. So C and D. Now to see if it's differentiable, we have to figure out the derivatives. So I'm going to make another piecewise here. So the derivative from the left, the derivative of x plus 5 is just going to equal 1. The derivative of our bottom is going to be 2x plus 2. And we're still going to keep the same x values. So x is less than negative 2. X is greater than or equal to negative 2. And then like before, we just plug them in. So from the left, we have 1. And on the right side, I have 2 times negative 2 plus 2. So I get 1 equals, that's going to be negative 4 plus 2, which is negative 2. Those are not the same. So this one is not differentiable, meaning it can't be A, it has to be B. (29) wants to know where this is continuous but not differentiable. So this just means not the same slope from the left and the right. So let's just look at each of these points. So let's look at x equals 2. Looking right here, it's not even continuous, so it can't be A. 3, not continuous. So the limit exists, however the point is not the same, so not continuous. Now looking at 4, let me erase these other two. So at 4, the limit exists, left and the right limit are the same, and the point is the same. So it's definitely continuous, but you see how it's not the same slope on both sides? So here on the left, we have a slope of 0. On the right side, we have the slope of negative something. So those two are not the same values. C is our answer. And lastly, at 5, we have a hole. So that one's not even continuous. The answer had to be C. Number 30 asks for the instantaneous rate of change. So that is not going to be slope. That's going to be the derivative. So we want to find the derivative and then plug in the x value that they give us. So just f prime of x. Derivative of sine is going to be cosine. And then the derivative of negative 3 cosine is going to be positive 3 sine. So now all we have to do is plug in the point that they gave us, so pi over 2. So I have cosine of pi over 2 plus 3 sine pi over 2. And you need your unit circle here. Cosine of pi over 2 is 0. Sine of pi over 2 is 1. So our answer here should just be 3, or D. Okay, 31, we have slope of a tangent line. So slope of a tangent line, you should automatically be thinking derivative. We know our derivative of natural log is 1 over x. Derivative of 2x is just equal to 2. And then it gives us the x value, 3. So I need f prime of 3. So it's going to be 1/3 plus 2. And just because it's 1/3 plus 2, let's go ahead and change this to 1/3 plus 6/3, which we can see equals 7/3, or B. Okay, 32. So right here, we have g of x. They tell us all of our information about h of x, and then they define f of x. So I know f of x equals g of x times h of x. And we're looking for f prime, so I'm going to have to use product rule here since these two are multiplied by each other. So it's going to be the first times the derivative of the second plus derivative of the first times the second. So if I plug in a 1 here, I have g of 1, h prime of 1, plus g prime of 1 times h of 1. So g of 1 just comes from the graph. It's the y value at 1. So that's going to be 2. H prime of 1 they told us was 4. G prime of 1 comes from the slope. So he's down 1, 2 over 1. So obviously that's negative 2. They give us h of 1 is 3. So we get 8 plus negative 6 which equals 2. So our answer is A. 33, we need the derivative of x to the 4th times e to the x. Once again, these are two functions multiplied by each other, so we need product rule. So we'll start with x to the 4th. That's the original first function times the derivative of the second. Derivative of e to the x is just e to the x, plus derivative of the first, 4x cubed, e to the x. So that's our answer. However, it does not match either one of these. And if you look at your answer choices, it looks like we're going to have to factor something out. So I can factor out, looking at this, an x cubed e to the x. So if I take x cubed e to the x out of the first one, I'm left with just x. If I factor x cubed e to the x out of the second term, we're just left with 4. And the only one that matches that would be C, even though it's in a different order. Okay, on this one they give us a whole table, and it's going to be very similar to that graph one we did before. So we need the value of k prime 4. So if k of x equals f of x times h of x, once again just product rule. So k prime of x equals the first times the derivative of the second plus derivative of the first times the second. And then since I'm looking for k prime of 4, I'll just replace all of those x's with 4's. And then I just use my table. So f of 4 is going to be 2. H prime of 4 is going to be 3. F prime of 4 is going to be -3. H of 4 is going to be -1. So then I'm left with 6 plus 3, which gives me 9. So my answer is B. 35, so I have f of x equals 2x cosine x. Once again, I can draw a line. There's a function on both sides of that line, so I'm going to need product rule. So f prime of x equals the first times the derivative of the second plus derivative of the first times the second. Then I just got to plug in a 0, so 2 times 0 times negative sine 0 plus 2 times cosine of 0. All of that's going to become a 0, so I'm left with 2 times cosine of 0 is 1. So my answer is D. (36), they give us h of x equals g of x over f of x. So on this one, I'm going to need quotient rule. So I can say h prime of x is going to equal low d high minus high d low all over the square of what's below. Then I plug in the value they look for, which is 1. So f of 1 times g prime of 1 minus g of 1 times f prime of 1 all over f of 1 squared. Then I just plug in the values that they've defined for us all up here. So I can see that h prime of 1 is going to equal 4 times 3 minus 2 times 5 over 4 squared, which is 16. So if I do the math here, I get 12 minus 10, which is 2/16, which should equal 1/8, or B. So those questions are just testing, do you remember product and quotient rule? All right, 37. This is another one where we obviously have a numerator and a denominator, so we're going to need quotient rule. We're going to use that same rule. So f prime of x equals low, so 4x plus 1. Derivative of the top is going to be 6x minus 2 minus high, so leave that 3x squared, minus 2x. D low, so the derivative of the bottom, which is 4, all over the bottom squared, so 4x plus 1 squared. And none of our answer choices look like that, so we are actually going to have to multiply this one out. So when I do that, I get 24x squared minus 8x plus 6x minus 2 minus, so I'm going to distribute that negative and multiply those together, so 12x squared plus 8x the bottom's not going to change. The bottom's what we already want based on the answer choices. And then finally, let's just combine like terms. So 24x squared minus 12x squared is 12x squared. Negative 8x and positive 8x cancel, so we're left with plus 6x minus 2 over 4x plus 1 squared. And it looks like the one that matches that is going to be A. Okay, here we have a differentiable function. It's just natural log over h of x. But since we have something divided, we're still going to need quotient rule here. So f prime of x equals low. Derivative of natural log is 1 over x minus natural log x times h prime of x all over h of x squared. So f prime of 1 equals h of 1 times 1 over 1 minus natural log 1 times h prime of 1 all over h of 1 squared. So now we just use our values. H of 1, negative 2, 1 over 1 is 1. Natural log of 1 is 0 times negative 2 all over negative 2 squared. So now I simplify this, I get negative 2 over 4, which equals negative 1/2. So C is going to be our answer. Okay, 39 is just testing to see if we remember our trig derivatives. So the derivative of cotangent, this is one you should have memorized, just equals negative cosecant squared. Very easy question if you memorized your derivatives. Same thing with number 40. They're just testing. There's no special rules here. So the derivative of secant should be secant tangent. And the derivative of cosecant should be negative cosecant cotangent. So when you throw those together, you get secant tangent minus cosecant cotangent, which makes our answer D. And that's it for our first derivative.